Welcome. From nuclear physics, we are discussing about the radioactivity. Friends, in this lecture, we have to see what is the carbon dating or archaeological time scale. In previous lecture, we discussed about the radiological equilibrium. We know that there are three types of radiological equilibrium. First is a ideal equilibrium, second is a circular equilibrium or permanent equilibrium, and third is a transient equilibrium. In ideal equilibrium, the activity of a parent is equal to activity of a daughter. In a circular equilibrium, the parent live extremely longer time than the daughter, or we can say that the half life of a parent is very greater than the half life of a daughter. In a transit equilibrium, the parent live longer time than the daughter, but it not much more longer time. The activity of a parent is greater than the uh, or we can say that the half life of a parent is greater than the half life of a daughter, but it is not much more. So these are the radiological equilibrium. In this lecture, we have to see what is the carbon dating or archaeological time scale. After attending this lecture, student will be understand about the carbon dating. Student can be find the age of the fossil. So let's begin. We know that there is a cosmic rays continuously form carbon 14 in atmosphere. Carbon 14, carbon have a different isotopes. That is a carbon 14, carbon 12. Carbon 14 is a radioactive isotope, while the carbon 12 is not so. The cosmic rays continuously form carbon 14. We know that when the neutron is combined with the nitrogen, it forms carbon 14 and hydrogen. Here the carbon 14 is a neutron rich, which consists of a 6 protons and 8 neutron. So that this carbon 14 is a radioactive and it emits beta particle. Here, when the this radioactive process is, the carbon 14 is a decay into nitrogen 14, and the beta particles are emitted, or we can say that the anti neutrinos are also emitted. When the animal or plant take a food or they take a breathe, it will take carbon 14 with carbon 12. The ratio of a carbon 14 and carbon 12 is a constant in a living animal or a plant. Living animal or plant continuously take carbon 14 with carbon 12, and the ratio is a constant. When the animal or plant is dies, it intake of a carbon is stopped. But here the carbon 14 is the radioactive. Therefore, decay of carbon 14 is continuously carried out. Carbon 12 is not a radioactive. The carbon 14 is a radioactive. So the ratio of carbon 14 to the carbon 12 in a living organism continuously change. By carefully measuring the activity of carbon 14 in a fossil or a dead trees, we can measure the ratio of carbon 14 to the carbon 12 continuously change, and by using this ratio we can establish the age of any fossil. Now I take one example. If we have to find the archaeological expression, that is we have to find the age of a fire pit, then we can say that uh, the carbon 14 have activity 11.3 count per gram per minute. The absolute activity of a carbon 14 in a living trees is independent of the species, and it is of a 15.3 count per gram per minute. And by using this we can establish the age of the charcoal. Here, according to law of radioactive decay, n is equal to n0 e raised to minus lambda into t, where lambda is a decay constant. N is considered as a number of radioactive carbon 14 atom at an instant t. N0 is a number of radioactive carbon 14 when the trees are living. That is the initial carbon atoms when the trees are living. N is a number of radioactive carbon 14 atom at a time t when the trees are dead. N lambda, the activity of carbon 14 at the instant, and its value is 11.3. Okay, count per gram per minute. Okay, this represent activity of a carbon 14 at a time t. It means that when the trees are dead, N0 lambda is the activity of carbon 14, and it is 15.3 when t is equal to 0, or initial activity of the trees when the trees are living. Now we know that activity at a time t is equal to activity, that is n is equal to n0 e raised to lambda into t. Multiplying both sides by lambda, we get n lambda. It is equal to n0 lambda e raised to minus lambda into t. Lambda is a decay constant. N is a number of carbon 14 atom at a time t. N0 is a number of radioactive atom when t is equal to 0. N lambda represent the activity of carbon 14 at a time t, and N0 lambda represent activity of a carbon 14 when t is equal to 0. This equation can be written as n lambda divided by n0 lambda is equal to e raised to minus lambda into t. This can be also written as e raised to minus lambda into t, it is equal to 11.3 divided by 15.3, because we know that the activity of the carbon 14 when at a time t is 11.3. Okay, that is when trees are dead. N0 lambda means activity of radioactive carbon 14 when the trees are living. Okay, that is at a time t is equal to 0, and it is 15.3. So we can write e raised to lambda t. Okay, taking reciprocal, we get 15.3 divided by 11.3. Okay, or we can invert the numerator and denominator, and therefore we can write e raised to lambda t, e, when e exponential term goes from left side to right side, it became ln, log of base 10. So lambda t is equal to ln of 11.3 divided by 15.3. So t is equal to 1 upon lambda ln of 11.3 divided by 15.3, And we know that the half-life of a carbon-14 is 5,730 years. Okay, and we know that the formula for half-life, that is the time required to disintegrate radioactive substance to half of its original value, is T is equal to 1 upon lambda, uh, or simply 0.693 divided by lambda. So this equation can be written as T is equal small t, it is equal to capital T, that is half-life, divided by 0.693 into ln of 11.3 divided by 15.3. So we get T is equal to 5730 divided by 0.693 ln of 11.3 divided by 15.3. When we calculate this, when we calculate ln of 11.3 divided by 15.3, its value is 0.3031. And therefore, T is equal to 2504.65 years is the age of a charcoal. So by using, we can find the age of a charcoal. So in this lecture, we discuss the carbon dating. When the animal, any animal, take a food or take a at a time of a breathing, it will take the carbon 14 and carbon 12. Carbon 14 is radioactive, while carbon 12 is not so. When the trees or animal is living, then the ratio of carbon 14 to carbon 12 is a constant. But when the trees or living animal dies, this ratio is a change. Ratio of carbon 14 and carbon 12 is a change, because carbon 14 is a radioactive. Okay, and therefore this ratio is a change. And by calculating this ratio, we can find the age of any charcoal or any fossil or dead animal. So this is the carbon dating. In next lecture, we have to see what is the radioactive series. Thank you.